So welcome my YouTube channel. My name is Anibroto Pal. I have several institute of teaching experience, almost 10 years. So I guided lots of my BTech students and MTech students, as well as also I am doing my PhD recently. I am going to submit in this year. So in this my small experience, I am going to teach all of you some different hectic points about the civil engineering, those areas where the students are facing more difficulties. So one of the today's subject we are going to discuss, that is the design of steel structure. That is the most convenient and easy subject I realize from my experience. Just because of you are providing codes, you are providing the formulas and calculator. So after getting all those stuffs, that is not so much difficult to solve the problem of the design of steel structure. So today our first video will be upon the design of steel structure with the topic of joints. So the joints, how many types of joints are there? Basically there are two types of joint. Number one, that is the lap joint, and the another one is the butt joint. So from this name we can easily assume that the lap joint, which is defined when the two plates are being overlapped, that is called the lap joint. Now what is the butt joint? When the two plates are internally connected end to end, not being overlapped, it is connected to the end to end portion, that part is called the butt joint. So now our point is how these joints are to be connected. That is our chapter, the bolt design. From here we can discuss our first today's discussion. So how that the bolt will be designed, that is the partial portion. First point, how the bolt is looking like. So now here you can see the diagram. So that is the structural component of a bolt. So there are, you can see three type of portion in this bolt. So which is this topper one? That is strong threaded head. That means the topper portion, that is the strong threaded head. Next, that is the portion where it is connected through head and the lower portion, that is called washer. And the lower portion, which is called as the end portion, called as nut. So that is the basic diagram of a bolt. Now the point is, lots of several types of bolts are available in our market. How many types of bolts are there? So bolts are divided two types. What is it? One is normal bolt, or you can call it nominal bolt. Now the question is, why it is called normal or nominal bolt? Cause there the FUB is limited to 400 MPa. That is the normal bolt. And another one is HSFG. That is called high strength friction grip. H for high strength friction grip bolt. What is the difference in between that the nominal bolt or the HSFG bolt? For the HSFG bolt, that the FUB limited start from the 800 MPa. Now for the gate students, those students who will appear in the gate, sir, what is black bolt then? The black bolt, which is also called as the normal bolt and the nominal bolt. Why it is called black? Just because of it is easily available for the market, easily used to in our all components to the structures. That's why it is called normal, nominal or black bolt. That is the two criteria of our bolt design. Now how the point is to be defined as the design portion. To design that the bolt, we will discuss about now the design. So basic some formulas and the values we have to remind before designing of the bolt. As we are discussing about bolt, so there will be the bolt diameter, that is denoted as D0, and bolt will be fitted to the bolt hole, that means that is the hole diameter, that should be denoted as DH. That is the two basic criteria, bolt diameter and the hole diameter. So what is the value of that? Every diameter it should be in mm unit, hole diameter is also in mm unit. So 12, 14, 16, 18, 20, 22, 24, 26, 30, 33. All these are in mm. Now question is, sir, is this the all limitation of the bolt diameter? Yes, this is the limitation of the bolt diameter, but after the market you can easily available more than 33 mm of bolt. But for our syllabus purposes and the examination, not more than 33 is not taking for granted. So for 12 mm, we can easily write here for 13, for 14 we can write here for 15. That means that is the plus 1 addition. For 16 to 26, that is the addition of plus 2. That means for 16 you can here it is 18, for 18 it is 20, for 20 it is 22, for 22 it is 24, for 24 it is 26, for 26 it is 28, for 30 it is 33, and for 33 that is 36. That means for 30 to 33 that is the add-on plus 3. I hope it is visible to all. That is the add-on value of the limitation. So how could I remind? 12 to 14 that is plus 1 addition, from 16 to 26 that is addition of plus 2, and from 30 to 33 that is addition of plus 3. Clear? Now we should have to discuss about the tensile stress. Just because of to calculation of that the bolt diameter and the hole diameter is not only about the problem things. Now in our formula we have to discuss tensile stress area. Tensile stress area, what it will be denoted as A and B. So that the tensile stress area, it should be denoted as the bolt dia, and that is the tensile stress area, that is A and B area. So the unit should be mm square. Small example of that is for 12 mm. Next we will go for 16 mm. Next we will go for 20 mm. So the tensile stress area, the value, it directly we can put here 84.3 mm square. For 16 mm that is 156 mm square. For 20 mm it should be 245 mm square. Now the question is, sir, if we forgot all the values, how could we remind in our exam? Very logistic question. So that is a key trick formula. That is that A and B you can calculate also if you didn't remind those values. 0.78 into pi by 4 into D0 square. So what is that D0? That is your value of that. What is D0? In our last description, the bolt diameter we denoted as D0. So if you put all the values and calculate it, your value should be almost nearest to that. But the calculated value and these values may be slightly different, but as you know we are designing, so in our design that is granted.